Hello, I'm Dr. Ajay Sharma, Department of Electronics and Communication Engineering, James Engineering Management Technical Campus, Greater Noida. The subject that I teach in this semester for BTech 5th semester students, Electronics branch, is digital communication. This is the main subject. And the topic that I discuss today is PDF, means probability density function, joint PDF, joint probability density function, and marginal PDF, marginal probability density function. So before we start, we once again focus on random variables. Random variable we already discussed in previous video lectures. But before we start density function, we should go through once again this random variable. A random variable has defined as a set of values with different probabilities. Means if you have different random variables, means different probability density functions of different probability distribution function. The meaning is that each random variable has its own probability density function. Not only that, each random variable has its own probability distribution also, right? So different random variable means different density function and different distribution functions, right? As far as random variables is concerned, random variables is categorized into two groups. One is discrete, another is continuous. Means random variable may be discrete nature, may be continuous nature. If random variable is a discrete nature, then this random variable has finite number of outcomes, and if the random variable is of continuous type of nature, then it has infinite possibilities of values. And the examples of this discrete type random variables is dead or alive, pass or fail, dice. If you play a Ludo, you have only 6 options, 1 to 6. So these are the discrete. I mean, you can count the outcomes, total outcomes or possible outcomes. But in continuous type, you can't count the things. For example, weight. Weight is increasing day by day. Or if you take any example of any person, height of a children, it's a continuous process, right? So these are some examples of continuous type of random variables. Now come to density function. Density function for discrete variable is similar to distribution function. Distribution function, we also know that, or we discussed this distribution function in previous video lectures. So density function for discrete random variable is similar to distributive function. Actually, probability density function. What is this probability density function? Probability of what? Probability of a random variable. What is the term density means here? Density means area. Every random variable has its own area where the existence of the random variable is to be searched, or is to be you also want to know the existence of any random variable. So you should have the idea of probability density function, because that PDF gives you the idea, the range of the probability range of the random variables. So you focus on that area to find out this, to know this random variable, right? So it can be considered as a smoothened distribution function, of course. So let us suppose capital X. So look at the capital X. Let us suppose capital X to be a continuous random variable and small x be the value that variable X takes. To understand this probability density function, we always take capital X as a random variable, and this capital X can have any values: small x1, small x2, small x3, x4, x5, x5, x3, x6, x7, dot 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 dot. So this x1, x2 are the possible values of capital X. So in short, we can say that x1, x2 represented by small x, right? So capital X declare capital X be a continuous random variable, and small x be the possible value of that capital X. So in such case, fx is used to describe density function. Look at fx. Fx is whenever fx is to be written, where f is in small letter. Remember this. F is in small letter. If you capitalize this f, then it has a different meaning. So probability density function of capital X in short written as fx, where f is small. So fx is probability density function, capital X in any continuous random variable, and small x be the any value that capital X takes, right? Now probability density function, this is the graph of a probability density function, and how you draw that? You draw that x, these are the possible values of x, x1, x2, x3, and on y-axis you have the value of probability density function fx. Look at this, look at the shaded region. You look at the shaded region between A and B. So the existence of x lies between A and B. So A and B are the limits, right? So density is between A and B of that random variable. So existence of that small x is to be find in between A and B, and fx is the density function, right? So this is the graph that shows the x lies between A and B. Density function example. Okay, we just start with some example to understand this probability density function. Suppose your client confirms an appointment between noon and 2 p.m. means 12 to 2 p.m. Right? Someone want to meet you between 12 to 2 p.m. Then here the time of arrival is absolutely random. Means the person can meet you between 12 to 2 p.m. Maybe the person come to you at 12:15 p.m. Maybe 12:16, maybe 1, maybe 1:50 p.m. So it's on. So it's a random. But we know the limits. Limits is between 12 and 2 p.m. So let capital X is the random variable for arrival time, and X be the possible values. So X can take any value between 12 to 2. So capital X is a random variable that gives the value of time in between 12 to 2 p.m. and small x be the possible values, and these are infinite values. Look at the case, the example. Look at the case 0 and 2. 0 means 12 to 2. 0 means 12 o'clock to 2, o'clock to 2, and this is the function. So if you say that if your client confirm that your client come to you at between 12:30 to 1, if your client confirm that person come to you between 12:30 to 1, so these are the limit. So the probability density function is changed particularly for that particular example. According to the example, this is the shaded region. If your client confirm that the client come to you between 12:30 to 1, look at the shade region. So this shaded region is the probability density functions, and client come anytime between 0.5 means 12:30 to 1 at any time, right? So this is the example that gives you the idea how you draw the probability density functions. You always take the variable at x-axis and its probability density function at y-axis. So this is the example to understand probability density function. Look at the definition. We already discussed in this lecture, so it's very much easy to you to understand the definition. What is the definition? A probability density function PDF is a function that describes the relative likelihood for the random variable to takes on a given value. I think you understand that. It is given by the integral of the variable's density over that range. This is also be clear. Means if you integrate, if the PDF is given to of any random variable, if you integrate that PDF in the limit that you already know, then you have the value of that random variable. To find the value of the random variable, you always integrate your PDF function by the range given as, by the limit given as in the particular numerical, right? So when you have a probability density function, it always given you as a range. So what you have to do, you have to just integrate the PDF with put the limit or the range where this particular variable is, the possibility of the variable is to existence of the variable is to be find. It can be represented by the area under the density function. That is clear. That I already told you that. It can be represented by the area under the density function and above the horizontal axis and between the lowest and the greatest value of the range. This is also clear, right? There are some few properties of probability density function. These properties are very important, and out of 10, 8 times this particular question had been asked in the examinations. What is explain probability density function and explain one or two properties of probability density function. So this is very important. Number one property of probability density function: fxx is greater than or equal to 0 means probability density function is a non-negative quantity, means it is always above 0 or 0. It is positive quantity. So probability density function is always positive. It is greater than or equal to 0. Second, if you integrate your probability density function, look at this probability density function fxx, integrate with the limit, then you always get 1, and 1 is the 100% certain. It is a certainty. It is a 100% guarantee that so if you integrate the whole area, then ultimately you get 1, because 1 gives you the surety that the particular random variable exists, because random variable always exists in a particular range. So if you integrate the whole area, ultimately you get the value of x. So it's 100% things. So if you integrate probability density function with the limit, in general, it is minus infinity to infinity, and if it is specific, then this limits are to be given in the question. So if you integrate the probability density function, you always with the range there, then you always get 1. Sometimes this is the case. Sometimes a range is given between a and b, so you integrate with a and b. This is because the probability of finding this particular x, which is a random variable, is between a and b, so you have to integrate between a and b of this probability density function, and you get the answer. And fourth point, it is the derivative of CDF. What is CDF? Cumulative density function. So PDF always the derivative of CDF, right? This is the general concept. So where the PDF comes from the derivative of CDF. What is CDF? Cumulative density function. Look at this one example to understand this, because many times numericals may be asked in an examination on PDF rather than theoretical, rather than theory. So this particular question, what is given? You give the random variable x. We always take capital X as random variable, and its PDF is given. This is the PDF function. Fx is equals to k x minus x square, and look at the range. X lies between 0 and 1. So the range is given, the function is given. Then question is find k. It is very easy. What you have to do? You have to integrate this particular function with the limit this, and you always get 1. This is one of the property of PDF. So you have to just put 0 and 1, put function there, and integrate this. You will find this k barabar 6. So this is easy. So you have to prepare many other questions on this PDF, because the chance of numerical is more rather than the theoretical question on PDF, right? And these are easy one, and you get full marks if your answer is correct. For example, in that question, this question maybe asked in 7 marks sometimes in examination. And look at the level. It is just the integration, and you find the value of k. So students, not focus on numericals. They just go through the book and have a reading theoretically, and not focus on the examples of the numerical. And I always suggest students to please practice numericals, because numericals if you attempt the numerical, is if you know the numerical, if you have a practical, if you have if you prepare numericals well, and if you practice well, then hardly takes 2 or 3 minutes to solve the numerical rather than theoretical question. Because theoretical question sometimes takes 15 to 20 minutes, because you have to write many things in that. So please focus on examples and numericals. That's my point. Come to the joint PDF. What is joint PDF? When the joint PDF come in the picture, when you deal with 2 different random variables. For example, capital X, one random variable, capital Y is another random variable. Then if you combine these 2 random variables, then joint PDF come in the picture. So the joint PDF for X and Y is a PDF that gives the probability that each of X, Y falls in any particular range or discrete set of values specified for that variable. The joint PDF come in the picture when you deal with 2 different random variables, capital X and capital Y. Small x can have any values of capital X, small y have any values of capital Y. And there is some mistake there in this slide. The mistake is this is not a capital F, this is small f, right? please understand this is small f. So the capital F, this becomes CDF. Small f means PDF and capital F means CDF. So please make this correction. This is not a capital F, this is small f. And that gives you the joint PDF. So joint PDF of capital X and Y having values X and Y. What you have to do? Again, integrate the range. This is the first range of X, the second range is of Y. Then just integrate this particular, right? There are some properties of joint PDF. Number one property is joint PDF of any two random variable is always greater than or equal to 0. Means it is a non-negative quantity. Second, if you integrate both, if you integrate this joint PDF function with their limits that are given in the questions, then you will get 1. You will get 100% guarantee. Third, if you have a range, specifically a range, a specified range, then you have to put a specified range in the integration and you will get the probability. Look at this fourth one. This capital X lies between A and B and Y lies between C and D. So you have to put these two range in this particular expression and you get the probability, or you will say joint probability. Example, again, sometime instead of probability, the joint probability function is to be given there and you have to find what is K. Again, what you have to do, again, this is the mathematical expression, this is the property of joint PDF. Just put the limit separately, 0 to 1, 0 to 1, because X lies between 0 to 1, Y lies to 0 to 1. So you put these particular limits and just integrate, you get the answer. K is equals to 4. Look at. Then marginal PDF. Actually, marginal PDF, sometime from the joint PDF, if you want to extract single PDF from the joint PDF, then that particular single PDF become marginal PDF, right? If you have given, for example, if you have given this is a joint PDF of X and Y, and if you extract fxx, a single probability function, then this single probability function become a marginal PDF. Okay. Similarly, for the case of Y, if this is a joint PDF of X and Y, and if you take a single PDF Fy, this particular Fyy, this is also, I think this should be Fyy, then that become a marginal PDF. So marginal PDF are nothing but the single PDF that is coming from joint PDF. So if you have a joint PDF, if you want to take a single PDF from the joint PDF, then that single PDF become a marginal PDF. I think you heard this. This is the same slide, I think. And these are some examples. And this is one of the examples. Again, find X, find K. Thank you very much.